Hello viewers, welcome to the Civil Engineering Study and Construction channel. Here I am Devesh Bhattacharya, and today we are about to embark on an exciting journey into the world of construction of RCC Plinth beam of RCC frame structure building. The proposed building is set for the construction of plinth beam. In this video, I will describe everything about the specification of all the required materials, function of all the reinforcement components, different moments and stresses acts on the plinth beam, and overall the function of this plinth beam. This video may be some long, so please stay tuned up to the end of the video so that you can understand all. For any work, I think we should know the specification properly, other than which no work can be executed perfectly. Therefore, at first, I am stating the specifications of all the materials required in this work. This is HYSD or High Strength Deformed Reinforcement Bar. Reinforcement is the backbone of RCC structure. The correct size, spacing and placement of reinforcement bars as per IS codes ensures strength, safety and durability of a structure. These HYSD bars should be according to IS 1786-2008, grade of which may be FE 415, FE 500, FE 500D, FE 550 and FE 600. As per IS 456-2000, clause number 26.4, the minimum concrete cover in this beam should be 25 mm. For severe environmental exposure, increase this cover by 10 mm. While using, the bars should be free from visible defects, rust, loose scale, oil or grease. For this plinth beam, the minimum tensile steel should be 0.85 into BD divided by FY, and minimum compression steel should be 0.25% of cross-sectional area of the beam. This is coarse aggregate of concrete, that is stone chips. Quality of stone chips is a prime factor for making a good concrete. For concrete work, the selection and grading of stone chips is governed by IS 456-2000 and IS 383-2016. Aggregate should be graded as per Table 2 of IS 383-2016 to ensure a well-graded mix. Commonly used sizes are 20 mm, 12.5 mm and 10 mm depending on the structural element. It should be hard, durable and free from impurities such as clay, silt and organic matter. Water absorption should be less than equal to 2% by mass. Crushing value should be less than equal to 30% for ordinary concrete and less than equal to 45% for non-structural work. Impact value should be less than equal to 30% for wearing surface and less than equal to 45% for other concrete. Angular aggregates are preferred for better interlocking. This is fine aggregate for concreting, that is natural sand. Fine aggregate should conform to IS 383-2016. Sand is generally divided into 4 zones, Zone 1 to Zone 4. Based on particle size distribution as given in Table number 9 of IS 383-2016. Zone 2 is most commonly used for concrete work. The sand should be clean, free from silt, clay and organic impurities. Silt content should be less than equal to 3% by weight when tested as per IS 2386 Part 1. It should not contain any harmful impurities like alkali, salt, which might cause corrosion. Fine aggregate should have a fineness modulus of 2.6 to 3.2 for most concrete works. Sand exhibits bulking when moist. This must be considered during proportioning. Concrete mix proportions should be designed as per IS 10262-2019 for achieving the desired strength and durability. The water cement ratio, aggregate size and grading significantly affect the workability and strength of concrete. Now this is cement. There are different types of cements are available in the market. But which one can we use for the RCC work? For RCC work, cement is the most vital ingredient. Indian Standard Code of Practice specify detailed requirements regarding its type, grade, quality, storage and testing. I am stating here in detail. IS code specifies the types of cements are generally permitted for RCC work. Number 1. Ordinary Portland cement. This is as per IS 269/2015, grade of which 33, 43 and 53 grade. Generally used OPC 43 and 53 grade. Number 2. Portland Puzzolana cement. This is as per IS 1489 Part 1 and Part 2 2015. This cement is fly ash based or calcined clay based. This is widely used in RCC due to durability, low heat of hydration and economy. Number 3. Portland slag cement. IS 455/2015. It is used in coastal or marine area and in aggressive environment works. Number 4. Rapid hardening Portland cement. This is as per IS 8041/1990. This is used for early strength requirements. And number 5. Sulfate resisting cement. This is as per IS 12330. This is used in foundation, sewage and sulfate rich soil water areas. Now stating different properties which should be in cement. Number 1. Fineness. This is as per IS 4031 Part 2. The minimum specific surface should be 225 meter square per kg. Number 2. Setting time. This is as per IS 4031 Part 5. Initial setting time not less than 30 minutes and final setting time not more than 600 minutes. Number 3. Compressive strength. This is as per 4031 Part 6. For OPC 33 grade, 33 MPa in 28 days. OPC 43 is 43 MPa at 28 days and OPC 53 equal to 53 MPa at 28 days. Number 4. Soundness. This is as per IS 4031 Part 3. Expansion not more than 10 mm by Le Chatelier method. Number 5. Consistency. This is as per 4031 Part 4. Standard consistency of cement paste should be 26% to 33% water. Number 6. Storage of cement. This is most vital and as guided in IS 4082/1996. This must be stored in dry, leak-proof godown. Stack not higher than 15 bags. Used within 3 months of manufacture for best result. Friends, these were the specifications of all the materials required in the work. Now moving to the construction. Here concrete is being prepared using a mechanical mixture instead of hand mixing. It ensures uniformity, speed and quality control, especially for medium to large scale works. Before preparation, ensure that the drum is clean, free from hardened concrete or any debris. Loading sequence of materials in the machine has been suggested in the Indian Standard Code of Practice 456/2000 in clause number 13.2.1. It stated that first place coarse aggregate inside the drum, then add fine aggregate, that is sand, next add cement. Finally add water, preferably through a measuring device. This sequence avoids cement sticking to the drum and ensures uniform mixing. The code also stated that the mixing time should be minimum 2 minutes after all materials including water in the drum. For larger mixers, mixing time may be 1.5 to 3 minutes depending on the capacity. Concrete should be discharged immediately and used within 30 minutes of mixing. If delay occurs, initial setting of cement may reduce workability. Friends, see here, the shattering and reinforcement work of this plinth beam is in progress. Now question is this, that why should we provide this beam in the building? Yes, Now I will discuss about the utility and the importance of the plinth beam in a building. A plinth beam is a must and a critical component in a building's foundation system. It is made of RCC, which consists of cement, sand and aggregate, and steel reinforcement bars. The steel provides tensile strength while the concrete handles compressive loads. It is constructed between the foundation and the superstructure, typically at the plinth level, that is above the ground level and below the floor slab. Plinth beams are used in load-bearing structures, frame structure with RCC columns and walls, and seismically active regions to enhance structural resilience. It has several utilities. Number 1, it transfers the load of the superstructure, that is walls, columns, etc. evenly to the foundation. Number 2, it bridges minor differential settlements in the soil, preventing cracks in the structure above. Number 3, it acts as a horizontal tie to hold the footings and the foundation together, improving the building's resistance to seismic forces. Number 4, it keeps walls intact against lateral soil pressure or other ground movements. And number 5 is it helps to prevent moisture from seeping into the walls by raising the structure above ground level. So friends, it is clear that the plinth beam is an unavoidable and a vital structural member in a building. Now friends, I am going to the discussion of the different component of the reinforcement of a plinth beam, including different stresses, moment and shear. In case of a simply supported or continuous plinth beam of a building, the maximum positive bending moment or sagging bending moment occurs at the midspan of the beam, and maximum negative bending moment or hogging bending moment occurs near the supports of the beam. It means the tensile stress occurs at the bottom of the beam and at top near the two supports, whereas compressive stress occurs at the top of the beam. Therefore, we have to provide the longitudinal main reinforcement of the beam at bottom of the beam. In addition to this, we have to provide main reinforcement at top also near the two supports. This may be curtailed as short pieces. Friends, see in the video that we have provided 3 number 16 mm dia longitudinal main bars at bottom of the beam to handle the sagging bending moment. At top, near all the supports, 1 number extra top bar of 16 mm dia has been provided to handle the hogging bending moment. As at the top of the beam compressive stress occurs, so there is no need to provide any reinforcement for this compressive stress because concrete alone is sufficient to handle the compressive stress. But as a hanger bar or construction stability, we have to provide minimum 2 numbers top bar longitudinally. Now I am stating a very important point for which we have to provide main reinforcement bar at top and bottom, both face of the beam. Main bars are required at both top and bottom of the plinth beam when it is connected to RCC columns. This is because the beam experiences bending moment and forces that vary along its span, and these forces can create tension on both the top and bottom at different points. In seismic regions, plinth beams play a role in resisting lateral forces, which can cause alternative tension and compression zones on both faces of the beam. In the case of an RCC plinth beam in a building, there are generally no upward earth pressures acting directly on the beam unless the soil below the beam is expansive or exerts heaving forces due to specific conditions like as swelling, clay or freezing water content in the soil. Typically, the beam is designed to transfer loads from the superstructure to the foundation and is not in direct contact with the soil beneath. So friends, in conclusion, I will say that for better safety, we have to provide the main reinforcement at top and bottom of the beam, both face. Now stating about stirrups. In RCC beam, stirrups, which is also called shear reinforcement, are critical for resisting shear force and holding the longitudinal bars in place and provide additional strength to the beam. In Indian Standard Code of Practice 456/2000, in clause number 26.5.1.6, and 26.5.1.7 and in table number 5. Their specifications, spacing and design etc. are guided there. Stirrups resist shear force and prevent diagonal cracks caused by these forces. They are particularly critical in areas near the support of a beam where shear stress is maximum. Stirrups also improve the ductility of the beam and ensure that the concrete in the core remain confined, which enhances the beam's capacity to absorb energy and deform without failure. Stirrups are typically spaced closer together in areas with high shear stress and further apart in regions with lower shear stresses, following design guidelines. The 135-degree hook in stirrups is mandatory as per Indian Standard 2502/1963. Clause number 5.1.1 and IS 456/2000. The 135-degree bend followed by a 10D extension ensures the stirrup does not slip or pull out under shear or torsion stress. This encourages grips the concrete much more effectively than a 90-degree bend. Now I am going to the development length of the bar. Friends, I hope that you have already seen here that all the longitudinal bars of top and bottom of the beam are extended at the end in the form of L. It is the required development length of that bar. For accurate prediction of development length, you may please refer clause number 26.2.1 of Indian Standard Code 456/2000. It stated that LD equal to phi into sigma S divided by 4 tau BD, where LD equal to development length, phi equal to diameter of the reinforcement bar, sigma S stress in the bar at the point considered at the time of load design, and tau BD equal to design bond stress. Though this formula works for both the working stress and limit state method, the value for design bond stress is different for each. Friends, concreting of the beam is going on. The concrete is M25 grade and the water cement ratio is 0.45. Vibrator is being used where it is necessary. Using a vibrator during concreting is extremely important for ensuring good quality and durable concrete. IS 456/2000 stated in clause number 13.3.1 that concrete should be thoroughly compacted and fully worked around the reinforcement, around embedded fixtures and into the corners of the formwork. Using vibrator removes entrapped air voids from freshly placed concrete, ensures the concrete fills all gaps and corners of the formwork. It eliminates honeycombing and voids, making concrete dense, and dense concrete develops higher compressive and tensile strength. It reduces permeability by removing air pockets, prevents ingress of water, chemicals and salts, increases service life. It ensures full contact of concrete with reinforcement steel, provides stronger bond between steel and concrete, enhancing structural performance. Compacted concrete settles properly, giving an even smooth finish. It reduces need for excessive plastering or surface repair. It helps in uniform distribution of coarse and fine aggregates. Excessive or improper vibration may cause segregation, so correct usage is essential. Friends, these were all about the specification for the construction of RCC Plinth beam. Friends, if you found this video is useful to you, then please don't forget to hit the subscribe button and press the bell icon all, so you never miss an update from this channel. I have got lots more exciting and informative videos coming your way. Please feel free to share your suggestions in the comment box. Your feedback will help me to create content that best serves your needs. Thank you. Meet you again very soon with such type of video. Thanks again.